My matrix number is CE210236, and here I want to show you how to construct the ladder diagram using OpenPLC editor. So here the example diagram for activity 1. And after you finish design the diagram, run the circuit and wait for a minute so it show the PLC started. You have to debug to make sure you get the output. So first you need to turn on or close the PB1 and PB2 so the lamp will light up.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hasib Adinan. My number matrix is DE190100. Okay, for the activity number 2, simulation, we use the PB1, PB2 and siren. PB1 is the normally closed contact, PB2 is the normally open contact, and siren is the coil. Okay, so we run the simulation. Okay, because the PB1 is the normally closed, so the supply is passed through it without we force through the contact. Then to on the siren, we must force through PB2. Then will pass through the siren. Okay, that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zahir Shabi Umar. My matrix number is DE190194. For the activity 3, in this activity I have 2 PB. PB1 is normal and PB2 is negated, and also lamp. Then we have then we move to simulation. When PB1 force through, the lamp is on. When PB2 force through, the lamp will off.
So here we go for activity 4. First you need to design the diagram same as the lab sheet given. Then you need to repeat the same process, which is you need to start the simulation. So PLC started, and next you have to debug the circuit. The initial condition of the circuit show that the lamp will light up because of the contact used in this activity is normally closed. So that's why the initial condition we allow the current through the ladder diagram. So next we just to force we need to force the PB1 2 and observe the output of the lamp.
For activity number 5, this is the ladder diagram. So it have PB, this is the timer, and this is timer coil. This is the timer contact and lamp. Okay, timer contact we use the normally closed contact. Okay, so when we run the simulation, okay, we set the timer for 5 seconds. For initial condition, the lamp is in on condition. So when we force through this PB button, the timer will count down 5 seconds. Then this call will energize, then will trigger the timer contact and will turn off the lamp. Okay, that's all.
For the activity 6, in this activity have 1 PB, push button, 1 push button, 3 relay, 2 timers set as 5 seconds, also the indicator as lamp. Then we continue to simulation. We have the push button 1, relay 2 and relay 3 is forced to true. The relay 3 forced through, the lamp is on after 5 seconds, relay 1 is on.
So here I will give an explanation about activity 7. First, repeat the step, make the folder, make a new circuit, make a new project. First, repeat the same process from before. We need to create a new project, label it as ladder diagram. So next, we need to design the ladder diagram according to the lab sheet given. So as you can see here in this activity, we need to use the timer. So for timer, we need to put the variable here and type the variable, which is th 5000 millisecond equal to 5 seconds. So the amount in this diagram will be same as lab sheet given. So just construct a circuit. Run the circuit. Then you need to debug it, same as before. So as you can see, the initial condition of PB1 and PB2 is here. PB1 is normally closed. Then you need to turn on or close the PB1. Then the counter will start counting. Then after 5 seconds, it will trigger the coil and contact timer. So the lamp will be light up.
For activity number 8, the ladder diagram is same as the previous activity, which is activity 7, but the change only we made is the PB button here we change to the counter circuit, and the counter circuit we set to the 2 count. Okay, then we run the simulation. Okay. If we want to turn on the lamp, we must make the counter count until 2. So we pause through until 2. Okay, 1 and 2. So the timer will, the coil will energize. So will trigger the contact and the timer will count down to 5 seconds. Then this coil timer will energize and trigger the timer contact and lamp will turn on. Okay. To turn off this lamp, we just use the reset button, force through, then the lamp will reset, will turn off. Okay, if we don't want to use the counter circuit, we can use the push button here, R3. We force through the push button, then the same as the counter, will energize R1 and trigger contact R1, so the lamp will turn on. Okay, that's all.
For the activity 9, in this activity have 2 PB. PB1 is normal and PB2 is negated. 1 relay and lamp. Then we move to simulation when PB1 forced through, the lamp will on. When PB2 falls through, the lamp will off. For the activity 10, in this activity I have two push button. Push button 1 and push button 2 is normal. Then we have two push button stop that is negated. We have two relay, some negated and some normal. Then we have two lamps as indicator. Then we continue to simulation. When PB1 is forced through, the lamp 1 will on. When the PBS1 is forced through, the lamp 1 will off. Then when PB2 is forced through, the lamp 2 will on. When the PBS2 is forced through, the lamp 2 will off. That's it. Thank you.
Okay, for activity number 11, this is the ladder diagram which will have start PB, stop PB, R1 lamp 1, R1 contact, lamp 2, and R2 coil, R2 contact. This is the counter we use 3 count, and the time on delay timer is set to 5 seconds. Okay, we run the simulation. Okay, first we must reset the counter. Then when we force through this push button, the R1 and lamp 1 will energize. So the R1 contact will trigger, then it already count to 1. Okay, we must count to 3. The counter 2 and 3. So the lamp 1 will turn on, then the timer will count to 5. Then the R2 will turn on. Okay, so if we want to turn off this lamp and R2, we can reset the counter. Okay, that's all from me. Thank you.
So here we go again with activity 12. Activity 12, repeat the same process. You need to create a new project, same as previous activity. Then you need to construct the diagram. Make sure it's same as the lab sheet given. But for this activity, we need to add another component, which is counter. So the counter and timer should have their own variable. So the variable for the counter is 1%. Then set the timer variable into 2 seconds. So then you need to run the circuit. Then you have to observe here. You need to debug it. So the initial condition of PB1 is off and PB2 is on. So first off the reset button. Then you on the PB1. So the counter will be triggered and show the amount value of 1. Lamp for this section will light up. Then after that, to reset the circuit, you just need to turn on the reset button here. So this will discharge the so this will be energize the counter and allow current to flow through contact R3 to the timer. And after the variable of timer is achieved, the lamp 2 that is an indicator indicator as the reset. So the lamp 2 that act as the indicator for the reset system will be light up after 2 seconds. So I think that's all from me. Thank you.